Hello students. So let us continue with chapter 8 motion now. Learning outcomes of this video are draw ST, VT and AT graphs for a body for three different cases. First, when the body is at rest. Second, when the body is in uniform motion. Third, when the body is in uniformly accelerated motion. And I have already told you that we are going to consider in 9th class that always the motion is in a straight line unless something else is mentioned. Here I have written, but even if I don't write, you are supposed to consider that these motions are along a straight line. Now, you know S stands for distance or displacement magnitude, and V stands for speed or velocities magnitude, A stands for acceleration magnitude, and T stands for time. So draw distance or displacement time, velocity or speed time, and acceleration time graphs for a body for these three different cases. Now students, this is a topic which is very easy actually, but the beginning is very difficult. It means you should know certain basic things before we actually try to achieve these learning outcomes. So let us learn first what you have already been doing since your lower classes. Graph. You must be drawing graph in your maths notebooks. Now what is graph? You know that you must have seen during cricket also they show the bar graphs, where here we have number of overs along this axis and here we have number of runs scored in each over. Similarly, you must have seen many other graphs also. So let us consider the graphs which you will be using, okay, in your 9th class. So for that, we are going to see any graph has two axes. One horizontal axis called as x-axis and this one perpendicular vertical axis called as y-axis. And we assume here that the point of intersection of the two axes is O, origin. Okay. Now, we know that graph represents, in physics we talk about physical quantities only which can be measured. Okay. So, in these graphs, what is actually represented? On x-axis, we represent one physical quantity. On y-axis, we represent other physical quantity. Now, actually, we can plot any quantity here on x-axis and the other quantity on y-axis. But always, we should prefer out of the two physical quantities which we are going to take along these two axes, we should take the independent one. Now, why I have written variable here? Let us say, students, first of all, physical quantities can be constant or it can be a variable. Constant means the value does not change. Variable means the value is changing continuously. So here, independent, we are going to first of all take variables only. When we are going to draw the graphs, we are preferably taking variables, means physical quantities which are going to generally change. Independent variable means which we are selecting. And dependent variable means which depends upon this variable, this physical quantity. I'll explain you this. For example, if I say a person is running and after every 1 second I have to note down the distance travelled. So in that case, time 1 second, 2 seconds, 3 seconds, 4 seconds is my choice. So it means it is varying, but it is independent variable. I am choosing it. So I can plot the time here. 1, 2, 3 seconds like this. So this axis can be called as, in that case, time axis. And on the other hand, we are going to plot distance travelled by the person during this time. So distance travelled along y-axis. Now distance travelled is, I am not fixing because that depends on the person. Time I have decided 1 second, 2 seconds, 3 seconds. What will be the distance travelled for different persons? That depends upon different persons, and accordingly I can say time is independent variable because I am choosing it, and distance depends upon this time and it may vary for different persons. So that is a dependent variable. So students, while drawing graph, we should prefer to take the dependent variable along the y-axis and independent variable along the x-axis. Again, variable is nothing but it is a physical quantity which here changes. Now, you must have studied in your maths class that how to draw the graphs. Okay. First of all, we choose a scale. For simplicity, I will take this scale only, that in your graph paper, 1 centimeter is 1 unit. So then this will be 1, 2, 3. Here also I have taken the simple scale. 1 centimeter is 1 unit. So here 1, 2, 3. I could have taken the other scale also. For example, 1 centimeter is 2 units. Then it will become 2, 4, 6 along x-axis. And if I choose scale along y-axis as 1 centimeter is 4 units, then this will be 4, 8, 12 and so on units. It is a bit difficult thing, although it is not very difficult, but only the thing is you need to revise it properly. So you should know that graph represents variation of one physical quantity with respect to other physical quantity, and preferably we take independent physical quantity or variable along x-axis and dependent physical quantity or variable along y-axis. So for example, I have just noted down here, if x is 0, y is 0, this is the data available. Then I'll draw the first point. First point will be here. X is 0, y is 0, this point. For next, this x is 1, y is 1. This x is 1 and here y is 1. So I can draw a perpendicular here, point where they meet, that will be my point. Similarly, I can draw these 2 points also. This you have already done in your maths class. So here, you can plot all the points and then you can draw a line, smooth line passing through that. In this case, we can easily see that it will be a straight line passing through origin. So this will be a kind of graph that we obtain after I draw a line joining these points. That will be the graph. Okay. So here in this syllabus, we are going to choose the simple type of graph generally. Okay. Now, related to graph, we have a term called as slope or gradient. They mean the same thing. Slope of graph or gradient of graph, it means the same thing. What it is? Let us see. Let us consider this graph. Here, I already have a graph and let me choose any 2 points on it. A, B. Let the coordinates of A be x2, y2. It means when I drop a perpendicular from A on x-axis, let it be x2. When I drop a perpendicular from A on y-axis, this will be y2. Let the coordinates of point B be x1, y1. If I drop a perpendicular from B on x-axis, this is x1. When I drop a perpendicular from point B on y-axis, it will be y1. Now what is slope? For slope, I have chosen these 2 points and I am straightforward writing the formula for slope. Slope is y2 minus y1 divided by x2 minus x1. Now from this graph, we can see that this is y1 and this is y2. This distance is y1 and this distance is y2. And obviously, this distance AC, which is equal to AC is equal to this distance. Here, what is the value of AC? AC will be y2 minus y1, because this distance is y1, this complete is y2, so AC will be y1 minus y2. So I have written here AC is y2 minus y1. Now BC. BC is what? BC is equal to this length, and I can easily see that from O to this point it is x2, from O to this point it is x1. So obviously this BC is equal to this distance, and it will be this distance. Distance does not mean that it is necessarily distance. I am just saying distance on the graph. Okay. What will be the value here? BC, x2 minus x1. I'm sorry, it is not necessary it will be distance. It can be anything which is plotted on this x-axis. So x2 minus x1. So AC is y2 minus y1. BC is x2 minus x1. I have written here slope is y2 minus y1 upon x2 minus x1. And from this I can write slope is equal to AC upon BC. So when I draw this dotted lines and form this triangle ABC, How I have drawn this? I have dropped a perpendicular from A on x-axis, from A on y-axis, from B on x-axis, from B on y-axis, and I have produced this line perpendicular to this line. Okay, so now ABC is a right angle triangle where AC is perpendicular and BC is base. So now I can write slope or gradient of graph, which originally I have written is equal to y2 minus y1 upon x2 minus x1. I can simply remember that in this case we can say slope is equal to AC upon BC or perpendicular upon base. I know students, this is actually you will at the beginning you will find it a bit difficult. It's not difficult. These things you have already studied in your lower classes. Only this topic is new. Slope of graph or gradient of graph. Just remember this is y2 minus y1 upon x2 minus x1 or AC upon BC or perpendicular upon base. Now this will be one physical quantity. This will be other physical quantity. It means our slope is a ratio of these two physical quantities. So obviously slope is also representing a physical quantity which is different than these two physical quantities. And the unit of slope will be, as I have written there, unit of slope is equal to unit of y divided by unit of x. You will understand this better when I continue with this topic and try to start drawing these, explaining these type of graphs. Okay, just revise this gradient topic. Now here students, you can be asked to draw a graph, ST graph, VT graph, AT graph for a body at rest, and you can also be asked to write the nature of graphs for these three different cases. Okay, let us see now first ST graph. What you should do? Take two axes and make them meet like this. Call this axis as time axis. I have written the unit inside the bracket. Either you can put the slash t slash second or t then bracket second. Here distance time graph, so it will be S here. You can write in bracket the unit meter or slash meter. Now when time is equal to 0. Suppose if the body is at rest, it means when time is 0 seconds, distance is 0 meter. When time is 1 seconds, obviously the body is at rest, so distance will be 0 meter again. And after this 1 second more, that means when time is 2 seconds, it will still be 0 meter and it will continue. For all the times, distance will remain 0 meter. So when I draw this points, plot the points at 0 time, this distance is 0 meter. So at 0 time, when time is 0, distance travelled is 0, so I will get this point. When time is 1 second, distance travelled is again 0, so this will be my second point, this third point, and I can continue like this. And if I draw a line passing through these points, I will get this line. Okay, you can actually draw it bit darker. Here, I have drawn this darker. It means this is just simply the axis, but this is my graph. So this is graph, a straight line on the time axis. Okay, so you can easily draw ST graph. If you are asked for a body at rest, you should write this way. And if you are asked to write what is the nature of graph, you can write a straight line on the time axis. Hope you have understood this. Now let us proceed to VT graph for a body at rest. We know that if a body is at rest at 0 time or 1 second, 2 seconds, 3 seconds and so on, velocity or speed will remain 0 meter per second. Again when I plot the points, I will get the points as I have shown here. 1 second's velocity is 0, 2 seconds velocity is again 0, 3 seconds and continuously like this. Okay, so again I have shown this part darker till fourth unit. So this represents that my graph, the 4 points are lying on the time axis, and when I draw a graph, it will be a straight line on time axis. So I hope you can easily draw the VT graph for a body at rest, and also you can write down the nature. What is the nature of VT graph for a body at rest? Again a straight line on time axis. And similarly, we can easily show if a body is at rest, there is no velocity value continuously, it is 0. So obviously velocity is not changing at all, it is remaining 0 only. What is acceleration? It is change in velocity in unit time. When velocity is not changing only, what will be the change? 0. So acceleration value will continuously remain 0 meter per second square, and in the same manner we can draw the graph and we can write again that the straight line on time axis is the nature of AT graph for a body at rest. Hope you have understood and you can draw the graphs for a body at rest. ST graph, VT graph, AT graph, and you can write down their nature also. Now students, if you see the NCERT textbook, you will see the ST graph like this. So obviously you may feel that what you have studied now is wrong, but you know that we were 100% right there. Then how come this graph is there? Just have a look at it carefully. At 0 time, S is having certain value. And as time passes, that value remains the same. Now, if a body is at rest, we cannot say it has travelled some distance at 0 time. Obviously, distance travelled should be 0. In this case, it is showing certain value, but it is remaining fixed. So, remember, to be more specific, this is not ST. It is an ST graph, but it's not distance time or displacement time graph. We can say more perfectly that it is a position time graph. It means there is some origin. The body is lying at some distance away from the origin, okay, but it is remaining at rest. So we can get this type of graph. It is like if you consider your school to be origin and you are, let us say, 100 meter away from your school, but you are standing there only for next 5 minutes. So your position is 100 meter away from your school origin and you are staying there only when time passes for the next 5 minutes. So in that case, still you are at rest. But then this ST graph will be your position time graph and not distance or displacement time graph. So in your NCERT book, this S stands for position. Okay, we cannot take it distance or displacement. Clear? So what is the nature of position time graph for a body at rest? It can be a straight line on the time axis if the body is at the origin only, or it can be a straight line parallel to time axis if the body is away from the origin as you are away from the school. Now let us consider the next case when the body is in uniform motion. Students, you have to remember that it is a uniform motion along a straight line. Now if you are asked to draw ST, VT and AT graphs, let us see how to draw ST graph. Now in this case I have written reading, but if readings are not given, then also you should be able to draw the graph. First let us see how we have drawn the graph here. S along y-axis, T along x-axis. When time t is 0, I have chosen a scale here first of all. What is the scale chosen? 1 centimeter is 2 seconds. On x-axis and on y-axis 1 centimeter is 4 meters. So when time is 0 seconds, distance travelled is 0 meter. When time is 2 seconds, let the distance travelled be 4 meter. When time is 4 seconds, distance travelled is 8 meter. When time is 5 seconds, total distance travelled is 10 meter. Now we already remember, you should remember the definition of uniform motion, that when a body covers equal distances, like here 4 meter, 4 meter, 4 meter, equal distances in equal intervals of time, here we have, here see 2 minus 0, 2 seconds, 4 minus 2, 2 seconds, 6 minus 4, 2 seconds. So in every 2 seconds, the body is travelling how much distance? 2 meter, 2 meter, 2 meter. So these are the readings we can say this is the data for a body in uniform motion. And as I have explained you earlier, if we draw the graph 0 second, 0 meter, 2 seconds, 2 seconds, drop a perpendicular like this, distance travelled is 4 meter, 4 meter, draw a perpendicular and where they meet that is a point, okay. Next 4 seconds, 8 meter, 4 seconds, drop a perpendicular like this, 8 meters, 8 meters, drop a perpendicular on distance axis like this and wherever they meet, that is a required point. Similarly, you can continue and draw the points on the basis of data that is given to you. So in that case, when you draw a line passing through all these points, you will see that our graph for uniform motion will be like this. Okay, so how is the graph? It is a straight line inclined to time axis. It is not parallel to time axis, it is inclined to time axis. Okay, so what is the nature of ST graph for a body in uniform motion or uniform motion along a straight line? A straight line inclined to time axis and passing through origin. Here I have written the nature in words. Okay, now speed or velocity time graph. Why I am saying speed or velocity? Because it is a motion along a straight line. So I can call it ST, I can call it distance time, I can call it displacement time. Similarly here, I can call it VT, speed time or velocity time graph. Now we know when a body is in uniform motion, its velocity or speed remains constant along a straight line. So let us consider that the body is in uniform motion with speed 50 meters per second. Okay, so in that case, if I choose this scale as I have shown here, then at time t is equal to 0, my object is having speed 50 meters per second. After 1 second, it is again 50 meters per second. So here we have a body in uniform motion with speed 50 meters per second. Because we know for body in uniform motion, speed remains constant. So if we choose 50 meters per second to be the value of speed for a body in uniform motion, at 0 time speed is 50 meters per second. After 1 second, 50. After 2 seconds, 50. If I plot these points and draw the graph, it means draw a line passing through all these points, I get this graph. Okay, so here this graph is for which case? For speed time or velocity time graph for a body in uniform motion. What is the nature you can say? Nature is here, a straight line parallel to time axis. Okay. Next, acceleration time graph. As in the case of a body at rest, we have seen that acceleration remains 0 for a body at rest because the velocity remains 0. There is no change in velocity. Similarly, in this case, although velocity has certain value, it's not 0, it is having certain value, but the value remains same. It means there is no change in velocity. And what is acceleration? Change in velocity in 1 second. So since the velocity is not changing, there is no change. So acceleration value remains 0, and so accordingly we can draw the AT graph for a body in uniform motion as shown here. What will be the nature? A straight line on time axis. So students, I hope you have learned how to draw ST graph, VT graph and AT graph for a body in uniform motion. ST graph, you can write the nature straight line inclined to time axis and passing through origin. Speed time or velocity time straight line parallel to time axis, and AT graph straight line on the time axis. Okay. Let us consider the case when a body is in uniformly accelerated motion. Now, for a body in uniformly accelerated motion, students, remember the definition of uniformly accelerated motion? Try to recall it. What it is? When the velocity of a body changes by equal amounts in equal intervals of time, the body is said to be in uniformly accelerated motion. It means velocity is changing but by equal amounts in equal intervals of time. And again we are considering that the motion is along a straight line, so we can use the word speed and velocity interchangeably or distance and displacement interchangeably. Now in this case, let us first see VT graph. Now I have chosen this data for a body in uniformly accelerated motion. When time is 0 second, what is the velocity or speed? 0 meter per second. It means the body is at rest. Time after 1 second, it is 5 meter per second. After 2 seconds, the speed or velocity becomes 10 meter per second. After 3 seconds, it becomes 15 meter per second. So here we can easily see that in every 1 second, speed or velocity magnitude is changing by same amount. How much? 5 minus 0, 5 meter per second. 10 minus 5, 5 meter per second. So velocity is changing by 5 meter per second in every 1 second. And if we use this formula, In this formula, I have not chosen V minus U upon T. I have chosen this because there are many readings. So instead of U and V, in such case when there are many readings given, we can use V1, V2, V3, V4 instead of using U and V. So acceleration we have seen here that it is 5 meter per second square and it remains constant. So we can say this is the data given for a body in uniformly accelerated motion. Again, by using the same method, first plot the axis, velocity axis, time axis, origin, time t is 0, velocity is 0 meter per second. When it is 1 second, draw perpendicular on time axis from 1 second. Velocity is 5 meter per second. So 5 meter per second, draw perpendicular on velocity axis. Wherever they meet, that is our point. In the similar way, we can get 4 points for these 4 readings like this by drawing the perpendiculars from these different readings on the 2 axes. So when I draw a line passing through these points, I get a graph, VT graph for a body in uniformly accelerated motion. So we can easily see here that what is the nature of velocity time graph? It is a straight line inclined to time axis and passing through origin in this case. So for a body which starts from rest, nature is a straight line inclined to time axis and passing through origin. But let us see this graph. Now I have drawn another line. I have not shown the readings here. I have just drawn the graph directly. You can see that this is a straight line inclined to time axis only. It is not parallel. But is it right for this case? Yes, it is right. But what is the difference? That it is not passing through origin. It means when time is 0, it is having certain value. Here the value is lying between 5 and 10. Somewhere we can say 7.5 meter per second. It means what? The body is in uniformly accelerated motion, but when we started noting the time at 0 time, the body was having certain value of velocity. It was not at rest. It was having velocity 7.5 meter per second. So both these graphs, if you draw for body in uniformly accelerated motion, they are right. The difference is this graph is for a body when it starts from rest. This graph is when a body is already in motion. Okay. So overall then, if we are asked, give the nature for VT graph for a body in uniformly accelerated motion, we can write a straight line inclined to time axis. Now, to draw AT graph, as we see that from the definition we know that value of acceleration remains constant with time for this case. And in this case we have seen that acceleration remains 5 meter per second square. So if we plot the graph as I have explained you earlier also, we can see that the graph is straight line parallel to time axis. Okay, so nature of AT graph for a body in uniformly accelerated motion is straight line parallel to time axis. Now let us see how to draw the ST graph for a body in uniformly accelerated motion. Now this is the last graph that we are going to see in this learning outcome. For a body in uniformly accelerated motion, we are going to study ST graph. I have not taken the readings here because we know that imagining the reading ourselves will be a difficult task, but we can understand this graph even without the readings. Now, in the uniformly accelerated motion, when the acceleration is positive, it means velocity is increasing by equal amounts in equal intervals of time. And if I suppose, let me imagine that if we have if you have a data for such kind of motion, and when you draw the graph, your graph will be having this shape. It means you can get for 1 second you are getting this distance travelled, for 2 seconds you are getting total distance travelled as this total here, and 3 seconds this is a total distance travelled. Okay, if you have data and if you draw the graph, you will get 1, 2, 3 points like this, and in that case these points are not in a straight line, they are not collinear. So obviously in that case you cannot draw a straight line using the scale passing through the 3 points. Then you have to free-handedly draw a smooth curve passing through the 3 points. Okay, now here this part, this shape, just before we do this, let me tell you, you must have heard about the different shapes like circle, square, rectangle, triangle. Let us just see, have a look at this shape. Now this U shape, whether it is this way or inverted, okay, this shape is called as parabola. Okay, just like circle is a kind of shape, this shape is having the name parabola. Even if you draw half part of it, it will be a part of parabola. So if I have the readings and I draw the points for this motion, I get 1, 2, 3 points like this, and when I draw a curve using free hand, I draw the curve, I get the curve this way, which is a part of this shape. So now I'll say, what is the nature of the ST graph for a body in uniformly accelerated motion? Parabola. So just remember this, we will not be using this graph too much in our syllabus, but at least you should know to answer to this question. What is the nature of ST graph for uniformly accelerated motion? Parabola. It is a kind of curve. Okay, I have drawn these two graphs. Both are representing ST graphs and both graphs are curves. And we can say they are part of this parabolas only. It means both are applicable for uniformly accelerated motion. Then what is the difference? Just have a look at the first graph. Here, when I see in first second, what is the distance travelled? This is the distance travelled in first second. In the next 1 second, what is the distance travelled? I am not asking you total 2 seconds. In the next 1 second, what is the distance travelled? This. Okay. In the next 1 second, what is the distance travelled? Draw the perpendiculars like this and then draw the perpendiculars on S-axis like this. And then further, distance travelled in next 1 second will be still, you can draw the perpendicular and the distance travelled will still decrease. So we see that as time passes, when we take equal intervals of time, distance travelled is decreasing. When we have already accepted that this is the case of uniformly accelerated motion, as the distance travelled is decreasing, we can say that it is a graph for positive or negative acceleration. It is a graph for negative acceleration because velocity must be decreasing. That's why distance travelled is decreasing. And in that graph, if we see, if we drop the perpendiculars from 1, 2, 3, 4, 5 on time axis, and from the point of intersection on the graphs, we draw the perpendicular on this x-axis, we can similar way, we can see that distance travelled in the first 1 second is such small, distance travelled in the next 1 second is little bit more, next 1 second is again increasing, next 1 second again more, again more. It means as the body is in motion, as time passes, distance travelled in equal interval of time is increasing. And if we have accepted this as a graph of uniformly accelerated motion, since the distance travelled is increasing, velocity must be increasing. So it is a graph for positive acceleration. So overall, if I ask you what is the nature of graph, ST graph for a body in uniformly accelerated motion, it is parabola. This is just for your knowledge that you should be able to distinguish between the two graphs, whether it is for negative acceleration or positive acceleration. Now let us summarize how to write the nature of different graphs for different cases. Now let us consider for a body at rest, nature of graph, ST graph, a straight line on time axis or a straight line parallel to time axis. You know this is a case when S stands for position. VT graph, a straight line on time axis as velocity value remains 0. A straight line on time axis for AT graph because acceleration value also remains 0. So when the value remains 0, what is the nature of graph? A straight line on time axis. In uniform motion, what is a ST graph? A straight line inclined to time axis. Okay. VT graph, a straight line parallel to time axis. AT graph, a straight line on time axis as acceleration remains 0 for this case also. In uniformly accelerated motion, nature of ST graph, parabola. VT graph, straight line inclined to time axis. AT graph, straight line parallel to time axis. This learning outcomes of today's video are a bit difficult. I know it is difficult to achieve at first go. Please do revise these topics, then only the topics will be clear to you, and only when today's learning outcomes have been achieved, you can proceed further. Hope you will revise and understand these topics very well. Thank you.